Dirt plus 2 coins equals free electricity. Can't patented. Now illegal. Welcome back to Historia Prime, where we dig into the forgotten chapters of human history to find knowledge that still matters today. On February 15, 2021, the state of Texas went dark. A polar vortex knocked out the power grid for nearly 5 days. Over 4 million homes lost electricity. People froze in their own bedrooms. Grocery stores were empty. Cell phones died, and with them, any connection to emergency services. At least 246 people lost their lives, not because the technology to survive did not exist, but because an entire population had been made completely dependent on a single centralized power grid. Now here is a question that might sound absurd. What if, during that blackout, you could have pushed 2 different pieces of metal into the wet ground outside your door and generated enough electricity to power a light, run a small radio, or even trickle-charge a phone? What if that method has been known for over 2,000 years? This is the story of the Earth battery. It is one of the oldest electrical concepts in human history. It is a lesson in survival, self-reliance, and why some technologies get adopted while others quietly disappear. Not because they fail, but because they do not fit the business model of the age. Let us journey through time, unravel the science of soil, and discover how forgotten knowledge from the past can still empower your life today. 1. The 2,000-year-old enigma. Our story does not begin in a modern laboratory. It begins beneath the desert sands of ancient Mesopotamia. In 1936, during an excavation near Kujut Rabu, close to the ancient city of Ctesiphon in modern-day Iraq, a German archaeologist named Wilhelm Koenig made a discovery that sparked decades of debate. Koenig, who served as director of the National Museum of Iraq, unearthed a small, vase-like container made of bright yellow clay, about 15 centimeters high. Inside this terracotta pot was a cylinder made from sheet copper, and suspended in the center of that copper cylinder was a completely oxidized iron rod, sealed in place with a stopper of asphalt. This artifact dates back to either the Parthian or Sasanian empires, roughly 250 BC to 650 AD. When Koenig examined the arrangement, he realized it resembled a rudimentary galvanic cell. In 1938, he proposed a radical hypothesis. This was an ancient electric battery. Could it be? Did ancient people harness electricity 2,000 years before Alessandro Volta built his famous voltaic pile? Scientists put the theory to the test. After World War II, an American engineer named Willard Gray built an exact replica of the jar, filled it with grape juice, and measured between 1.5 and 2 volts of electricity. Decades later, the television show Mythbusters built 10 handmade replicas. Using lemon juice as an electrolyte and linking the jars in series, they produced 4.33 volts, enough to visibly electroplate a small coin overnight. Now, to be fair, the majority of archaeologists remain skeptical, and their reasoning is legitimate. No ancient wires have been found alongside these jars. No written records describe electrical use. The leading alternative theory is that these vessels were simply protective containers for storing sacred scrolls, and the copper and iron components served as structural fittings. But consider this from a broader perspective. Electricity is not only useful for running machines. Even a mild electrical sensation produced by these jars could have served a purpose in ancient religious rituals, simulating divine power, or in primitive forms of pain relief through electrical stimulation. We may never know the definitive answer, but the chemistry is irrefutable. 2 dissimilar metals, separated by an acidic liquid, will produce an electric current. That is not opinion, that is physics, and it has been true since before the Romans laid their first road. The Earth, it turns out, is full of the ingredients to make this reaction happen naturally. Wet soil is acidic. It contains mineral salts. It is rich with organic matter. The ground beneath your feet is, in a very real sense, a giant electrolyte waiting to be tapped. 2. The Scottish clockmaker and the science of soil. Fast forward to 1841. The telegraph is becoming the internet of the 19th century, connecting cities and nations at the speed of electricity. But powering these early telegraphs required bulky, expensive wet cell batteries that leaked acid and degraded rapidly. Every telegraph station needed constant battery maintenance, and the cost was enormous. Enter Alexander Bain, a brilliant Scottish clock and instrument maker who was born into poverty as a shepherd boy. Bain had a deep obsession with electricity, and through relentless experimentation, he made a remarkable discovery. He drove 2 different metal plates, one zinc and one copper, into the damp soil behind his workshop, spacing them about 1 meter apart. When he connected a wire between them, a steady, sustained current flowed from the earth itself. Bain had created the first recorded practical earth battery, producing about 1 volt, which he successfully used to drive the mechanism of an electric clock. But how exactly does dirt produce power? The science is elegant. It relies on a phenomenon called galvanic corrosion, a fundamental principle of electrochemistry. When you place a zinc plate and a copper plate into wet soil, the soil acts as an electrolyte, a medium through which ions can travel. Soil is naturally rich in water, mineral salts, organic acids, and even microorganisms that enhance ionic conductivity. Because zinc sits higher than copper on the electrochemical series, zinc has a stronger tendency to lose electrons. Those electrons flow through the connecting wire from zinc to copper, creating an electrical current. As long as the soil stays moist, this silent, invisible exchange continues. Think about that for a moment. No fuel burned, no moving parts, no noise. Just 2 pieces of metal in wet dirt and electricity flows. Telegraph operators quickly saw the potential. By the late 1840s, earth batteries were being tested on sections of the telegraph network. Technical reports from the era document these experiments. The technology worked, it was reliable, and it was essentially free. But here is the critical detail. Free is a problem for anyone whose business depends on selling energy. A power source that comes from the ground cannot be metered. What cannot be metered cannot be monetized. And as the industrial age progressed, this simple economic reality would shape which technologies thrived and which ones were quietly left behind. 3. The tragic genius of the Kentucky Hills. To truly understand both the potential and the heartbreak of Earth energy, we need to look at the life of Nathan Stubblefield. In the late 1800s, Stubblefield was a farmer living in Murray, Kentucky. He was not a wealthy aristocrat or a member of the scientific elite. He was a self-taught experimenter who read scientific journals voraciously and spent every spare moment tinkering in his workshop. In 1898, Stubblefield was granted U.S. patent 600,457 for what he called an electric battery. But this was no ordinary battery. It was an electrolytic coil of iron and insulated copper wire buried deep in the ground. Stubblefield found that by utilizing the galvanic reaction between the metals and the soil, he could harvest usable energy from the earth. But he did not stop there. Stubblefield used his earth-powered system to do something extraordinary. He built a wireless telephone. In 1892, he handed a telephone receiver to his neighbor, Rainey Wells. Wells walked away from Stubblefield's workshop, and to his complete astonishment, he clearly heard Stubblefield's voice coming through the device, transmitted without a single connecting wire. Many historians believe Stubblefield achieved this through electromagnetic induction, using the conductive ground as a coupling medium between buried coils, essentially transmitting audio signals through the earth itself. If that is what happened, it was a genuine engineering achievement, years ahead of its time. Stubblefield scaled up his work. In 1902, He traveled to Washington, D.C., and successfully demonstrated his wireless telephone, transmitting voice across the Potomac River to an audience of scientists and journalists. The newspapers covered the event extensively. He had done something that, at the time, seemed impossible. So why don't we know his name? Why is Stubblefield not discussed alongside Edison and Bell? The answer is a painful mix of exploitation and principle. Stubblefield was targeted by fraudulent New York stock promoters who formed a company in his name for the sole purpose of scamming investors. Disgusted by their dishonesty, Stubblefield publicly denounced the company and refused to work with them. He was fiercely principled, but he was also deeply distrustful and difficult to work with, traits that isolated him further from potential allies and legitimate partners. There was also a genuine technical limitation. While the voltage of Earth batteries could be increased by wiring cells in series, the ampere. 4. Why you have never heard of this? So here is the uncomfortable question. If Earth batteries have been known since the 1840s, if they were used on telegraph networks and demonstrated before scientists, why are they completely absent from modern education? Why does no survival manual teach this? The answer is not a single conspiracy, it is structural economics. The global battery industry generates an estimated $150 billion in annual revenue, according to market research firms. That entire economic architecture depends on manufactured products that degrade, leak, and expire, creating a cycle of constant replacement. You buy a battery, it dies. You buy another one. This is a business model. An Earth battery, by contrast, renews itself every time it rains. You cannot build a recurring revenue stream on something that replenishes for free. But the deeper issue is not active suppression, it is passive neglect. Technologies that cannot be easily commercialized do not attract investment. Without investment, there is no research. Without research, there is no improvement. Without improvement, the technology stays primitive, and so it gets left out of textbooks, not because someone banned it, but because no one funded it. That said, there are real legal mechanisms that can suppress independent innovation, and they deserve a clear-eyed look. The Invention Secrecy Act of 1951 is a federal law that gives the U.S. Patent and Trademark Office the authority to review any patent application. If the government determines that publishing an invention would be detrimental to national security, it can issue a secrecy order, prohibiting the inventor from disclosing or even building their own creation. As of recent years, over 5,000 active secrecy orders are in effect. The law was originally designed for wartime weapons technology, and most of the orders likely involve military applications. There is no public evidence that Earth battery patents specifically have ever been targeted. But the legal mechanism exists, and that fact alone should make any independent inventor pay attention. And the friction against self-reliance shows up at the local level too. Consider the case of Virginia and Zach Loop, a family in Teller County, Colorado. They built a greenhouse at 9,200 feet of elevation to grow their own food year-round. To heat it affordably, they installed a geothermal ground loop system, burying tubes underground where temperatures remain stable, pulling warmth up in winter and cooling the structure in summer, all for roughly $1 a day. Now, to be precise, a geothermal ground loop is a different technology from a galvanic earth battery. One moves heat, the other generates electricity. But they share a common principle. Both draw usable energy from the ground itself. And the loops ran into the same wall that Earth battery pioneers have always faced. Their local government issued a stop work order and demanded they tear down the greenhouse, citing zoning and permitting violations. A family trying to grow their own food was told, essentially, to stop. The pattern is worth noticing. No one needs to ban the laws of physics. Zoning codes, permitting requirements, and bureaucratic friction can make self-sufficiency so legally exhausting that most people simply give up. The grid is not maintained by force. It is maintained by convenience and by the quiet assumption that there is no alternative. 5. Dirt power today, the science under your feet. So are we entirely at the mercy of the grid? Not even close. The beauty of understanding history is that once you know the mechanism, you can take the principle and run with it. The most exciting modern development in Earth energy is the microbial fuel cell, or MFC. Scientists have discovered that soil is not just a chemical electrolyte, it is a living ecosystem. Billions of bacteria in the soil consume organic matter and, as a byproduct of their metabolism, release electrons. By burying a carbon electrode in anaerobic, nutrient-rich compost and placing another electrode near the oxygen-rich surface, we can capture those electrons and generate electricity from biological activity. This is not science fiction. It is active, funded research being deployed in the field. A company called Labone Solutions has been installing soil-based microbial fuel cells in rural African villages where no power grid exists. A few square feet of wet, compost-rich soil can produce enough sustained power to charge cell phones and run LED lights for months. And the applications go beyond just electricity. Microbial fuel cells are being used to treat toxic wastewater, converting agricultural runoff into clean water and carbon-neutral bioelectricity. Think about what that means. The same biological processes that have been happening in soil for millions of years, bacteria eating organic matter and releasing energy, can be harnessed with simple, low-cost materials. The Earth is not just storing energy, it is actively producing it, right now, beneath your feet. And you do not need a laboratory to apply this knowledge. If you ever find yourself in a blackout, a camping emergency, or a genuine survival situation, remember Alexander Bain and his 2 metal plates. Here is a rapid earth battery you can build in 20 minutes with common materials. You need copper wire, which serves as your cathode, and galvanized steel nails, which are coated in zinc and serve as your anode. Find a patch of moist, mineral-rich soil. Push 1 galvanized nail and 1 piece of copper wire into the dirt, leaving a few inches between them. That single pair is 1 cell, producing roughly 0.5 to 1 volt at very low current. Now wire them in series. Connect the copper of cell 1 to the zinc nail of cell 2, and so on. By linking 10 to 15 pairs in wet earth, you can build up to around 10 to 12 volts of open circuit potential. Here is the honest limitation. The voltage adds up, but the amperage remains very low, typically in the milliamp range. That means you are not going to fast charge a modern smartphone with dirt. But you can absolutely power an LED light to see in the dark. You can run a small AM radio to receive emergency broadcasts. And with patience and a basic voltage regulator, you can trickle charge small devices over time. That is real, practical survival capability that costs almost nothing and requires no fuel. It works day and night. It does not break if you drop it. And unlike a conventional battery that leaks and dies on a shelf, an earth battery renews itself every time it rains. Is it a replacement for the power grid? No, but it is a tool. And in a genuine emergency, knowing this tool exists could be the difference between sitting in the dark and having light. Conclusion: reclaiming the lost science. As we look back at the 2,000-year-old jars of Mesopotamia, the quiet genius of Alexander Bain, and the tragic brilliance of Nathan Stubblefield, a profound lesson emerges. The history of technology is not always a straight line of progress. Sometimes decentralized and resourceful ways of solving problems are left behind, not because they failed, but because they did not fit the economic model of their time. The Earth battery teaches us that power does not only come from massive plants, spinning turbines, or global supply chains. Sometimes power is quiet. It is subtle. It is the steady electrochemical pulse of the soil beneath our feet. Remember that Texas blackout? 246 people died because when the centralized grid failed, there was no fallback. The Earth battery will not replace that grid, but it reminds us of something essential, that understanding how the world works at the most basic physical level gives you options that total dependence never will. By learning these forgotten sciences, we do more than study history. We develop genuine survival literacy. We learn to look at our environment not as a convenience to be taken for granted, but as a living system we can work with. We learn how to keep a light on in the darkest of times. Thank you for joining me on this deep dive into the hidden history of energy. If this video opened your eyes, hit that subscribe button, ring the bell, and share it with someone who values self-reliance and practical knowledge. Every share helps preserve the kind of knowledge that history left behind. Until next time, keep questioning, keep exploring, and remember, the power is quite literally beneath your feet. This is Historia Prime. Stay curious, stay prepared.